So Dinesh, I'm not sure if you want to do, you're kind of running this show. I don't know if you want to do a quick introduction of yourself, because there's new members who actually don't know who you are or any of us. So I'm not sure if you want to do a quick introduction. If we don't have time for that, we can, just table that. It's your call.
Yeah, we'll just quickly go through that. So maybe we'll just give another minute to everyone join, and we'll start. There will be a little noise behind me, but that's my everyday life. So just pardon that.
So, Dinesh, I think Felicia is trying to join. She should join.
Sure.
So if you can go ahead and, I guess, begin. I don't want to delay us too much. No.
Okay.
Yeah.
Thank you, John, for update. So we'll start. Myself, Dinesh Mende. I'm a part of IFH IT team, and my day-to-day role is basically working with research databases, writing new web applications for research, even writing public-facing websites, and also creating mobile apps. So my role varies, but it also has a lot of interesting stuff. So I enjoy a lot. And as you know, that for every application, whether it's a web application, whether it's a mobile application, whether it's a desktop application, everyone needs a sort of database. So that's why I will be taking on this series and going through relational databases. There are multiple types of databases, but we'll be mostly focusing on relational database in this series. And if anyone interested in non-relational databases, we do have some use cases for a few of the applications that we are using specifically non-relational databases, such as MongoDB and document-based database. So if anyone has question, please feel to reach out outside this meeting to talk about non-relational databases, because relational database itself is a vast domain, so it will take a long amount of time to go through all of the do's and don'ts and all of the processes involved. And thank you for joining today's meeting. John, I don't know if you have anything else to cover in the startup session, or we can jump in directly to the session.
Let's begin.
Okay, perfect. So I will quickly share the GitHub link, and that will be basically our presentation slide. As we, let me share with everyone. So as we go on our everyday session scheduled bi-weekly, I will be putting all the material, whether it's table structure, databases, queries, tips and tricks, everything will go to that repository. So make sure to save it, and we'll be accessing that again and again. I'm going to share that same screen. Let's see. Sorry, is able to see my screen?
Yes.
Perfect. So right now in this repository, you might be able to see there's a README file. And there's one folder which says day one, SQL Basic Queries. So every session, there will be one additional folder which will get added to this repository. And every folder itself will have a README file for each of the session. So README is basically GitHub way of saying it's a index and documentation page where you can reference what it is about, what it is, and all that. So let's go back to the main page. And we will be, so basically relational databases, there are multiple RDBMS right now in the market. If you look at Stack Overflow, MySQL is the top most widely used, and it is open source, which is purchased by Oracle very recently. So what we will do is we will do general purpose introduction to SQL. Why general purpose introduction? Because the basic concepts of SQL applies to all of the relational databases. There is no exception. there are a few additional things that every relational database has, but that can be learned very quickly when you know the basics. So I would say for relational databases, for JavaScript, for other object-oriented programming languages, or procedural programming languages, there is a standardization community. Same as for the SQL, basically. There is a one committee who decides the standard. And once we have the list of standards, the implementation group, it might be either open source community or a private company, they take that standard and implement their own application based on that standard. So that's why you will find all the relational database system, whether it's Oracle, whether it's IBM DB2, whether it's a SQL Server, whether it's a MySQL, Postgres, you will see they follow the same pattern. And just because of that, because there is a standardization committee which decides the standard, what standards they follow, and everyone follows that standard. So I would say it's basically the standardization committee provides the interface, right? The interface is like a blank slate, which just says what each of the thing will do. It doesn't give the implementation detail. So they provide the interface, and the implementer, whether it's Oracle, whether it's any open source community, they implement that function based on that interface design provided by the committee. So we will majoritarily work on general purpose SQL, and eventually at the end of this series, we have very specific sessions designed to deep dive into specific databases, relational databases. To avoid spending most of the time in implementation detail, installing application, we will be using online editors. And online editors are as powerful as your regular databases, except it has very limited storage capacity because it's provided online. So I also listed here the online editors that we will be using throughout this series. And at the end of series, where we have specific databases, then we will install those relevant databases onto the machine, and we will work specifically on that specific interface, whether it's a MySQL workbench for MySQL, whether it's Postgres editor for the Postgres database, or related to SQL Server or Oracle. So we'll go into that at the end of the series. Out of this, it's really up to you which one to use, but I would recommend SQL Fiddle. There is a reason for it. Oracle needs registration. So I don't know if you're comfortable doing registration now and doing all that processes before accessing it. DB Fiddle is, what it does, DB Fiddle, I'll just go through that interface. You have here a DDL schema. DDL is basically creating database, creating table, and all that. So every time you run any query, it goes through both the thing. It will create the schema and it will run the query. So instead of creating schema at once and running the queries independently, it does both the thing every time, every iteration. Whereas SQL Fiddle, it's a little bit more optimized. Although the website is not secure, which they should, but that doesn't matter to us because we are just practicing and using the test databases and test table and test data. Here you can build your schema beforehand, and you can use that schema later for each of the query. So this is a benefit. So it basically will be a little bit faster compared to the DB Fiddle. And Oracle needs registration, so we'll be skipping that for now. The other benefit is you can choose different interfaces from here if you're interested in jumping the hoops and doing and giving trial and error to other stuff also. So you can change the editor type to specific database and practice right here itself. But as we'll be going through more general purpose, so we'll just keep MySQL 5.6 and we'll be writing query based on that. Now, going back to, so that's mostly for editor. Now we'll go through each of the sections that we'll be discussing. I know there are people here who has different level of experience. So just have a patience a little bit for other team members because we'll be going through all the basics, right from how to create an entity, like how to create a table, how to choose based on the data or based on the requirement, how to choose which fields to take to build the table. We'll go through that. There are specific patterns that you need to follow to create a table. So let's get into it. First, introduction. Relational database is basically invented by E.F. Codd while working at IBM. And the relational database has a very specific purpose. Because before there were punch cards and there were other tapes which are very slow, and the way of storing data on those things are very inefficient, right? So if you have a large amount of data, then you need to find a way to store it very optimally so that you can retrieve and do other CRUD operation. So whenever I'm going to use CRUD operation means like it's a create, read, delete, and update. Those are 4 operations, and those are the basic operations that we usually perform on each of the record. Or even when you're accessing some website, whether you are just visiting a page, that means you are reading it. When you are creating your account, that means you are performing create operation. Suppose you go to that same web page and you update your personal details, that means you're doing update operation. And if you delete your account, that's a delete operation. So the CRUD operation is kind of a building block of relational database. And it's also a building block for all the web application or the, I would say application, whether platform independent, whether it's a mobile, whether it's a desktop. Those are the main 4 operations that goes into the picture most of the time. The Web 1 basically was mostly just for reading. Now you might be hearing Web 3 a lot. The Web 1 was basically when all this started. Mostly all the websites were just for information purpose, right? So you used to visit a website where you can just read the stuff, get the information, and that's it. Web 2 was more involved, where you had to do, you had more privileges to do additional stuff. Like consider Facebook is a Web 2 website or web application, Twitter, YouTube, where you can create your account, where you can create your own content and put it for the world to see it. And Web 3 is basically more towards the cryptocurrencies, virtual avatars, virtualization. We'll not discuss that right now. But all the Web 2 is basically mostly depends on the relational database. So, and why the relational database came into picture is basically dealing with the large data and how to optimize it so that the retrieval or any CRUD operation is faster. Because they notice the inconsistency or the lag in the operation when the data wasn't organized, right? When it's like in the flat file, then the accessing the data was very complicated. It took like more CPU cycles to perform any operation than it is required, than it should have been required. So that's where this idea of relational database came in. Basically, E.F. Codd, he coined this idea, presented this idea, and then it widely implemented in a lot of places. So the main building block of relational database, I would say, is indexing. And indexing is very important. Every programming languages, whether it's a R, whether it's a Python, whether it's a Java, without indexing, their own internal compiler may fail, or it will take a large amount of time for themselves to work. So indexing is very crucial for the databases. So why indexing? Indexing is basically when you have a list of items and you have a way to uniquely identify each of the item, then it's easy to find it in a large pool of stuff, right? So that's why indexes is very important, because you're able to uniquely identify that record. Same as when you store it into the table or in a file system, the Windows behind the scene or any computer behind the scene, it indexes everything. That's how you're able to search and sort. And behind the scene, it assigns a unique number. We don't notice it in day-to-day operation, but everything that we store on the computer, whether it's a Windows, Mac, or Linux, the operating system behind the scene assigns the unique number. And that unique number is basically index number. The UUID is widely used index number. UUID is a concept where, serial number in Excel is also a unique identifier, because each row you can identify with that row number, with the serial number. And UUID came into picture. Basically, UUID gives you more space, like a large length of, I guess, around 3 quintillion set of possible variations that you can do with the UID, because it's a 128 bit length series. So that's how UID came to picture. And mostly nowadays, you might have noticed when you receive a data set, you might see that 16-digit hexadecimal string, which uniquely identifies each record. So that hexadecimal string that you see is basically index number. It's nothing but index number, is just the representation is different to store a large set of data or large amount of rows. And for indexing, there are different ways how we can create index, which will go into the details afterwards. And how to create indexes and what things to watch for, what are the key types. We will also go into that in detail later. So just consider the building block of relational database is index. Even for most of the programming language, as I said, indexes are very important. Even when I said about programming languages, when they store the data, they also index it. There is a term which is like immutable and mutable data types. So that term itself defines when it's immutable means the compiler for any programming languages, it goes back into its storage and looks for it and then retrieves it to deliver it to the user. Especially strings are immutable in most of the programming languages. So strings, when you create it, it's immutable object. It stays in the system and compiler refers it, interpreter refers it again and again. Instead of, suppose you define, maybe I will go through some designs afterwards. We will go through how that also works in a bit. I will go through the terminology for the relational database, which is defined here. It's very straightforward. We have rows. This is a row, right? And this is a column. And in relational databases, a row is also called as tuple or a record. So this one thing in a table is a row. And also you can call it a tuple or a record or horizontal entity. Why entity? Entity is basically human is an entity, right? Male, female. You can basically say those are entity. Like each distinguishable item is kind of entity. And whenever you create a table, you basically, even if you use your natural judgment, like this entity, this is like independent entity, and this entity should have this many attributes. Even you can use natural judgment, and then afterwards you can use some mathematical and some protocols to filter out what attributes to keep and what attributes to separate. So row is basically just a tuple or a record. So throughout the series, I might refer it as a record for each of the row in the database. Column is basically attribute. Suppose a student or an employee is an entity. Then for that employee entity, employee first name, employee last name, employee address, those are all attributes which defines that entity. So that's why you call it as attribute. And attribute is also widely used in programming languages, other programming languages as well. So column is basically attribute, which stores that specific value, attribute value in that column. You can also call it as a field or vertical entity. Table is nothing but an entity, and we'll go into that, how to create a table, what are the steps in decision making while creating a table. You can also call it as a relation, base, relvar. Those terms you can ignore for now. You can just say it as object, database object or entity, or just a table for the reference. And view is a derived derivative. It's basically, view is a virtual entity. It doesn't exist in it doesn't exist, or it doesn't write on the disk to store it. It's basically a virtual representation of data, a subset of data within the table. I have been speaking for very long. If you guys have any question, feel free to ask. This is like mostly we can keep it as a bidirectional. If any term anything that you want to ask, feel free to jump in. We don't have to like follow the same structure, same pattern, and we can take care of the queries right away. Anyone has any questions till now?
No questions so far.
Okay, perfect. Now for the naming convention, so for every tutorial series, there will be tips and tricks and the naming convention. This basically you learn as you work in this field for a very long time. You start to realize the pattern, and I would say these are very useful. Refer this even for each of the individual session. There will be tips and tricks for those as well. So you can even make your own independent document and just collect those tips and tricks into the one page, like one pager. But right now they will be distributed throughout this page. So there's like tips here. So in between that you can refer and separate out for your own reference later. I guess I should have went through this. So on GitHub, it's very easy to reference. Only if you click edit, it's kind of a weird structure. This is like a markdown language. So you don't have to like look into it, just copy a bit. So if you're trying to copy by going into the raw, you will find like this weird structure, which is nothing but a markdown language. So I would say when you are copying it, just copy from this section like this, instead of clicking edit or clicking raw, because it will show you the markdown language, which is basically hard to read. And markdown language is also kind of limited set of tags, basically pattern. It's not too complicated to learn, but I will not suggest to learn it now. Now, for naming convention databases, the naming convention, most of the time what happens is, this is the most confusing part for the starter, data analyst, database administrator, data scientist, because what happens is you will see different variations in different places. It doesn't mean that one thing is right and one thing is wrong. It's basically how it is defined for their specific organization. So we'll go through the common one, best practices, but you can choose either of them. Nothing hurts. Before, there was a saying that, okay, if you use underscore in your naming convention, right? So this is a special character. So it is like additional overhead for interpreter or compiler to read. But nowadays, compute is not an issue, right? So your laptop, even if your personal laptop, they're way too powerful to handle a lot of data, a little bit of complexity. So using underscore, it's fine. Pascal casing. Pascal casing is basically if I write, let's see. So there are a few examples here that we will be running in a few. The Pascal casing is like this, right? So first name. So first letter is capital, name N is capital. So those are Pascal casing. Camel casing is first is small and the adjoint word is capital. That's a camel casing. Pascal casing is basically every word is capital. Every word's first letter is capital and they are joined together. So that's a Pascal casing. And so there are, if you read a book, they will say use Pascal casing. But if you refer large databases or even the one who designed RDBMS, like Oracle, let's take example of WordPress. WordPress, like almost 60% of the websites design which exist now on the web is designed using WordPress. So it's widely used. So if you see their naming convention, they use underscore. So the one who created a database, now there are multiple creators of database. So if one person says use Pascal casing because it's a best practice, but if you see implementer, so something who implemented it, like WordPress in this case, they use underscore widely for naming convention. So none of them are wrong. It's just basically best practices and you should follow what your organization is following. For me personally, I've been following underscore because there are cases where I had to separate out the names, but also it depends on the use cases. So the standards are basically don't use reserved keywords. So reserved keywords are, every language has a specific set of keywords. So never use that. Just like as an employee at IFH, your title is a keyword, right? So you cannot take that title and give a human baby name. That will be a lot of ambiguity. So that's why whenever, whichever language you are referring to, you should look into all the keywords that it has and try to avoid it to use for naming convention, right? Whether you are naming your table name, database name, whether you are naming it attributes, avoid those reserved keywords. The beauty of today's IDEs, or even small editors, even if you are using, VS Code, there is like Eclipse IDE for Java, your R has RStudio, it highlights those keywords. So you get to know it quickly that this is a reserved keyword. So nowadays you don't have to really worry about it, but that's something we should keep in mind, because you can actually still bypass it. You can interpolate it, and then you can still skip it while writing it. But it's best practice to avoid using keywords for naming convention. Avoid abbreviations. If you're working with a team, then avoid abbreviations, because one abbreviation means something for someone, one abbreviation can mean something for someone. Specifically, if you're international, you get very confused with the abbreviation. So avoid abbreviations. Avoid, this is like basically a white space. When I did this under double quote, this mean is basically don't use white space in naming convention. So suppose you're writing your first name. So I would say, don't put your first name and then space and the last name for the keyword, like first name when you're writing. So if we just look into this, so instead of keeping space between these two words, there is no space, because spaces adds ambiguity. People who are working in Python, they might know how important the spacing is, because that's how you can terminate your each line or function in Python, right? So you don't have to add semicolon. You can just leave without, you can terminate this statement without semicolon just by using space and starting new line with the spaces. So that's why space is very ambiguous. Avoid using spacing at all costs. Like absolutely make your habit not to use space. Oh, sorry, there is the single quote and the white spaces. So I should have looked at this. so there's a white spaces, which is basically that one I talked about. And there's also double quote. So double quote, it's, I should say double quote, using double quote in between the sentence. Suppose you have a sentence and that sentence itself contains some words where you need to quote it, right? So when you have to quote something within the sentence, and if you're storing that string into database, while retrieving it will be issue. And while even writing a query to retrieve it will be issue. So always avoid using double quotes in between the sentence. So use single quote inside the sentence, because when you query to the database, you define string or character within double quote. So you can define with a single quote also, but then that eventually when you work with a large amount of data, that becomes the issue. Use singular words. So that also, this naming convention of using singular words also varies organization to organization. Again, if you look into the large applications or widely popular application, they sometimes use plural. So really look into what your team and organization is using, and based on that, decide whether to use singular word or the plural word. Pascal casing, I just asterisked it because it really, again, your organization, look into what they're using, or whatever data set you're working with, look into what pattern they're following and follow that pattern to be consistent with it. All lowercase or underscore. So this is majoritarily used. So if you, this is my preference, but it really depends what your team prefer, and then you basically follow that pattern.
That's
If
just a
someone have-
convention. It doesn't break anything if you use a capital.
Correct. That's just the convention. It doesn't break if you use any. There are few databases, right? So who are case sensitive. They are sensitive, and there are majority of databases are not case sensitive. So even if you, so suppose I named this as first name, right? I can still write this in complete lowercase and refer to this attribute. That is definitely possible. So it doesn't break anything. But also it depends on the database. So, but I would say 90% of the databases, they are not case sensitive. So you can just write this one and still write in all small letter, all capital letter, you will be still able to access the respective attribute and row. So yeah, so that's a good question. It doesn't break anything. You can name it that way and then refer it in different multiple variation. But during comparison, right? So suppose you have to, suppose you are querying something, and when you're querying it, and if you're comparing two values, when you're doing comparison, always a good idea to make them lowercase. I'm talking about the values, when you compare the values. So you can actually first do the truncation and then convert them to all lowercase. That's the best practice while comparing the values. Why truncation? Because if there is a white space afterwards or before, then when you're comparing, your database engine may say it is different. But when you look at it, both values look same. All because of the white spaces, now you're not able to compare and you're getting the wrong result. Instead of the comparison value should say true, it's saying false because there is a white space. So while comparing values, the first thing always, this is the best practice. The first thing always to truncate, means truncate from both the sides, then make it lowercase and then compare. So that way you know that that you are comparing the right thing and for right value. Trigger names, these are basically, we'll go into the very last session, but this is how you should be defining your trigger, function names, and the store procedure. So, right, so how many MB and gigabytes of space you are going to, I would say avoid using it, because when you use varchar, which is another data type, you can basically, varchar is a dynamic enough that it keep track of what is the length of the value that is coming in for the storage. So the varchar, I would say use it more often than char, unless you know the specific length of a field and you are storing only that length of value each time. So a varchar is basically varchar, and also you depend, this little bit varies based on the database implementation. You can define the size, like whether it's a 10, 20, and all that. And when you use varchar, even if it's like a 10 length defined, and if I'm storing something in there, which is like less than 10 size, it will dynamically adjust it to that specific value size. But it has a little bit overhead. That row overhead is keeping track of length of that value. That's the only overhead, which is a bit length of overhead. When your computer talks to one computer, or even if you're when you're transferring file, how does your computer know when to end the transmission of that file? Because each packet it sends, it's persistently keep track of what is sent, what is not delivered, and all that, right? So to keep track of that, it has like a header values assigned to it. And that header values is basically overhead for most of the communication and transaction. So in varchar, although it's a dynamic, it's adjust according to the value size you are inputting in. It has little bit of overhead of keeping track of length of that value. But that's completely okay to ignore if you're working with a large number of database. And this is optimal way of storing it. So varchar is a place to go. Me personally, yes, I use varchar a lot and use char for the specific cases, just like a zip code, phone number, whether you're specifying Boolean types, but without saying it as a Boolean, right? And then also like male, female, gender, defining gender, MF. Those I know because if I'm going to, although on the visual side, when I submit the form, in the drop-down option, I'm saying it as a male and female. But when I'm storing in database, I'm just storing M word and F word. When application is reading that, now I'm letting application to handle to transcompile it to the specific value, which is whether it's a F is a female, M is male. So when storing in database, you are just storing, one character. So which does matter when you have millions and billions of record, right? So, but for those kind of cases, I will use char. Other than that, I would say use varchar. So varchar, widely used. Boolean, when you are storing. So Boolean is a little bit tricky because every database engine has a different variation of implementation. Although in Boolean use a true and false, but some databases save it as 1 and 0, which is kind of true and false. 0 means false, 1 means true. So although when you define it as a true and false, but when you're storing the value, you store it as 1 and 0. But yeah, Boolean for just storing true and false, something that only true length, single character stuff, defining true false mostly. There are some examples I mentioned here: true, false, yes, no, and all that. Now here I mention asterisks because depend on the database you're using, this 1 and 0 may be valid and this true false may be invalid. So it really depends on the database implementation, but it encompasses true, false, 1, 0, yes, no. Yes, no, you don't really type it, but mostly true, false, and 0 and 1. So integer, small int, decimal. So these are the number types. So the people who are using or coming from the background of SAS there are number types, right? There's a number, text, and there's a blob, there's a C blob, but number and text are widely used, and character. So this small int, decimal, numeric, all these are number types. It's just a different size of it, the way you specify it. So this here, what to choose when, and I did note here. I did note for char also. So just in future, you can quickly look into it when to use where. If you revise it 3-4 times, it will stay in your back of your mind, and you can use this as a best practice. So int and integer for storing whole number, right? So int and decimal maintains the precision. So now it comes with a cost. So when you have precision means, so suppose if I ask you to remember something exactly what it is, your brain will struggle and put more pressure to remember it. If I ask you something and then you say approximately, then you are quickly thinking and saying it. So it's like an easy operation. So int and decimal maintains the precision. The only overhead is the database engine has to perform a little bit of behind the scene operation to keep that precision intact. So whenever you need mathematical precision, you should always use int and decimal, right? And whenever you don't need it, then there are all the other float and double. They don't maintain precision. They maintain precision before decimal, but they don't maintain precision after decimal, right? So if you, mostly when you write value of pi, you write 3.14. You don't like write all of the series. So basically consider float is something like that. You don't, it doesn't matter whatever the values are. So when we don't need a precision, then you use float and double. But when you need a precision, then you should be always using int and decimal. And that's the most important thing to take away for the data types. This one we already discussed. Always use double quote for marking start and end, and then single quote in between words, sentences, and all that. You are sometimes whenever, for example, in a web application, you are storing patient history. Now in patient history, you are writing a whole paragraph. And then in that whole paragraph, when you are writing patient history, you also mention some keywords that you want to highlight. The way you highlight those keywords, either you put under the quote, or you mark it as a bold, or you color code it. Usually the medical applications or the web application you use, they don't give you like a nice GUI to color it and all that. They're most simplified because the whole purpose is to store useful information that can be retrieved and used later on. So now if in that paragraph of medical history, if I want to write something that is important enough so that the reviewer don't ignore that word, then you will put under the quote. Now, while using database, while querying stuff, now you're querying the string. So now you're putting double quote already at the start and end of the sentence. Suppose you have double quote in between the sentence, then your editor will give you error. Basically, it will not be able to read it properly. You can use other different options. There is a regular expression you can use. There are other functions like you can use just the string matching based on only few characters, but that's a different scenario. So always it's best practice to use single quote for the internal words, or before even starting your database analysis, I would say replace everything inside the sentence double quotes with a single quote. Because when you go deep into your analysis, you will hit a point somewhere where you are stuck, unless that the information doesn't matter to you. But if that information in the paragraph matters to you, then beforehand, do the replace operation, replace every double quote with single quote. Any questions till now? I know it's too much information, but without this information. Okay. So yeah, you will have to be just a little patient because if you want to do the querying, this is all the building blocks you will need to be a good database administrator, data scientist, data analyst. These are must things that either you will have to build by doing it or by learning it. So we will have to cover this. Now, there are date and time, timestamps. Those are also very important. Although when you refer date, date, timestamp, you always use double quote, right, during comparison, even while accessing and all that. So when storing it, actually you can store using even varchar, right? But when you later do the operation, you will have to convert or cast it. So casting is basically, if something is of one type, you need to cast it to some other type just because you want to compare two things. So that's a typecasting. It comes many times when you work with a large set of data. Typecasting will be like, even when you're writing function, procedures, trigger, there will be multiple places you will have to do typecasting, because there is something like, you cannot compare, you can only compare only by converting the stuff. The best practice always to store date, time, and timestamp are with their specific types. And every databases have this, like there is like no database engine without these types. So you will, whether it's Oracle, MySQL, SQL Server, you will have this type. So use these types to define in the column, that you're going to store date, time, or timestamp. If you don't use it, then every operation you do, you will have to do typecasting. Because technically, when you access the application and when you're filling the form, in some places you might see a drop down where you see the values or the calendar that you can access to input the date and time. For example, let's see here. If I go to a regular survey application, I'll just quickly give example. So in participant, I have date of birth, right? So here I can use this calendar. So what this does is it helps me to format it instead of user typing it, because user may type in thousands of variations. So most of the web application will have this interface. The web application which doesn't have this interface are basically screwed. And then it comes to the database administrator or the data analyst, data scientist to deal with that, right? Then you have to use different operations to filter it and make it a specific pattern to access it. But there are cases like this. There are in many web applications. Even if you see, even Microsoft has some other applications that I came across, which doesn't use like specific, drop down or any specific pattern to adjust it, and then later is basically dealing with that issue. Sometimes they keep it as backward compatibility because it's been the way been used. So for that reason, but the best practice is to have the drop down and then store them in the database side with their specific type. Now, there are Unix timestamp. So you might have seen a random number of digits. That's a Unix timestamp, but we don't have to look into it. Specifically, you can define timestamp with this, basically year dash month dash then day, and then time is basically separated with colon. And that's how it is stored behind the scene for those specific data types. So month, day, year are separated with dashes, and time elements are separated with column. Unix timestamp, if anyone is working with Unix timestamp, if they have any questions, feel free to ask. You can convert the Unix timestamp into the regular timestamps and date time to access it for comparison, because Unix timestamps are hard for comparison. And then also the implementer has to be aware of that it is Unix timestamp. So that's all about data types. You guys can walk through it. It's stored here, accessible to everyone. There are some do's and don'ts. There's another don't is basically not to put spaces whenever you're storing string or character or varchar, because ultimately either your IDE or the editor, it will truncate that, or your database will truncate it. If it's a varchar, database will truncate it. If it's a char, database will still store that spaces, but then it will truncate during the retrieval. So always avoid spaces unless it's necessary, which will be like this. This is necessary because you're storing a sentence, words, keywords, and like that. So you'll need space there. But avoid that mostly. And each data type has a specific size. Means, in memory, it takes this chunk of size. We don't have to go into detail to that. But if you have any queries, let me know. I can go through it. I guess there is one thing left is the character large object. Instead, just use varchar and text. I didn't define text here because text is not used in all of the databases engines. But text is where you have like a large limit of inputting the text, like paragraph. 1 page text content, 2 page text, and 3 page. So text basically are designed to store that type of data. But unfortunately, not every database engine on data RDBMS system has that. So people end up using varchar and then other data combination to make it work. The blob is basically binary large object. So whenever you store the image, now there are a way of storing images. So you can store images as a file onto the system, and you can store just the path into database, right? But also you can store image and convert into the machine code, right? Machine, then hex, then machine code is like binary 0, 1, right? And you can store into hexadecimal. You can convert that to hexadecimal. You can store that hexadecimal values into the database column. And then that is your image. Your image is represented as a number text right now because you can convert that to this and blah, blah, blah. Or you can store it into space somewhere, like a file system, and you can just store the path of that image into the database column. The problem is when you share the database, when you have the path defined into the column, you don't have the image, you just know the path because the computer which had that image is not with you. When you store into like hex, base 16 encoding, there are multiple types of encoding. Then you're storing everything inside that database column. And if you give that database to someone else, they will be able to recover that image. So storing only path and storing a converted format into database, it has own benefits and side effects. The storing that, the image itself, thousands of pixels, each pixel is represented in the machine code as binary. And that's why when your high quality image takes like, MB of space, whereas the low resolution image takes like a very less space in your phone, computer, just because of that. Because the number of pixel you have to convert each pixel into the binary. You can store in different format, but that's how machine understands. So if you have like millions of pixels, if say Apple says 4K retina, there are the millions of pixels, then you have to store the binary value for each of that. So it will take large space. If you're storing that image representation in your database, means your database will be consumed very quickly because you're storing all these bits into your database value rather than storing the path and then the conversion overhead. So it's a trade-off, right? It depends on, suppose if you are an Instagram developer, now Instagram has large data centers, so they can afford to have store the binary representation or hexadecimal representation, base 64 representation of that image into the database. But if you're a small data center, small storage space, I would say just store it as a file path into the system, and then store path into the in the database value, column value. Because then your database, whenever you are accessing the data, your database don't have to go through that large chunk of data to like find something and do it. It can just read that small path and then access that path to show you the file. So there are trade-offs. It really depends on the use case and the compute capacity you have. And the base 64 is like a widely used format to store the images and other file types, which aren't basically pure text or something else. Any questions till now?
Yeah. Again, no questions. Just
hopefully it's
very
not
intriguing, yeah.
too boring. If anyone has like
to me, it's very interesting, but I can't speak for everyone else.
But if you guys have out of context question, it is completely fine, because I'm also talking about how machine understands and all that. I know it's like not everyone's background. You guys are from healthcare background. I'm from computer science. So mixing that thing, for me, it's easy. But if you have any questions, feel free to ask. Like, if you, okay, why it is by base 64. Decimal is base 10, binary is base 2. Why it is like that, feel free to ask. So these are all data types. So I would recommend practice this, practice as much as you can, how to define what. This is important. If you want to create a database, if you want to define something in terms of relational database, you will have to know this. There is no getaway. You cannot get away from this. Unless you want to get away with it, but this is the building blocks basically. So yeah, these important things are, please keep in mind. They are very helpful. Now, these are all the valid, invalid things. You can go into detail on your own time because we're already running out of time. And remember, every RDMMS system has a little bit of slight variation, but it doesn't mean like they're completely different. And they will always have this base type implemented because there is a standardization committee who define the standards and they follow those standards. Now, the database we talked about indexing. There's a few examples here. The indexes and the keys are important. If you don't, the database is useless because now without indexes and without keys, it's basically if I give you some set of list of items and it haven't been like identified properly, right? And if I ask you to give me back, it will be challenging. So it's, maybe the best example is if I ask you to get me a chocolate from the store, it will be a round trip for you to either ask me what exactly the brand you need, right? It's like you have to like come back to me to ask it. Same, machines basically works the same way. If you don't specify it, or if it doesn't have a way of identifying something, that's why your computer fan will go up. And that's how your computer takes a lot of CPU and memory because it's having a hard time to find something. Your web browsers are like that. If they aren't able to index properly, they will also have a hard time to load the data. The cached items in your web browsers are also indexed, and also they have a specific key associated with it. And it finds that key and pulls based on that key the values that it needs to show it to you whenever you load the website. Because some website doesn't have round trip again and again to the server to fetch the data. Your browser stores a lot of information unless it is explicitly specified not to store it. So that's why indexes are very important to identify element in a database uniquely so that also database can perform the job efficiently and it can serve the purpose that is built for. The indexes are keys are basically a part of index and indexes. There are many ways of building indexes. We'll go into that later. But here I define the keys. So whenever you have a database and table, they will have a set of keys that you will be able to identify. Sorry. And so if, for example, Excel, when you put something in Excel, it already has the serial number that it assigns, which is its own way of indexing the stuff, right? If Excel doesn't have that, the load time of your Excel will increase rapidly. Although the serial number, you can also define your own index in Excel, which is like additional index for the Excel to index with. But yeah, behind the scene, a lot of application who deal with a large amount of data, one way or other, they do indexing behind the scene. So here the keys plays important role. Now in this table, you can see there are multiple attributes, right? So this is just a user table. And this table has this many attributes. Sorry, I just kept the small tables. So this is like I immediately put together a lot of stuff. But we could have showed many variations, but for now this should be sufficient enough. So there are attributes defined here, and each attribute has value. So there's a record, there are multiple records. There are 4 records right now in here. This 1, 2, 3, 4 is a unique number assigned to each of the rows. So this can act as a key, right? So this column can uniquely identify each of the rows. So this is a key technically. Now this registration ID is also key because it also uniquely identifies each of the rows. The email also uniquely identifies each of the rows. Now, what happens is there is a caveat. Lot of time, the web applications don't allow same email, and just because of that. And same as username, right? When you log in into Facebook, each user has a unique username because that's how the application find your relevant information in large database. So it has to be unique. So it's email, username, but there are applications where it doesn't matter for them to have repeated email. Just like some of the applications we have, and also we have applications where having unique email matters. So, but in this scenario, this one has unique value. So technically, all these columns which has unique value can act as a primary key. And then you can index with this. So it's not necessarily that you have to use only first column or the column with the serial number or the column with UID to be your indexing column. It can be anything which uniquely identifies your record. There's a misconception that when machine builds the index or when you define database in index, it has to be like serial number, UID, like number type, right? Although UID is not number, it's hexadecimal, which is combination of character because it has to add those digits to make it hexadecimal. So it can be anything basically. The indexes can be built with anything. Right now, I will not use first name and last name, but these are the example. But technically, here first name is also unique, last name is also unique, so you can use that. But in real life scenario, you might have users with the same name. And branch ID it's kind of repeated, so you cannot really use that. So super key is attribute or set of attributes that can use to identify these are the terms that you will come across while working in databases, and these are very important to keep track of. So super keys are basically the key with which you can uniquely identify the record. Now, super key can be a single key or the combination of key. It's not like it needs to have one column. It's not defined like that. You can have a combination of keys to uniquely identify the record within the database. A candidate key is a minimal set of super key, mostly built using only one attribute. So it's a minimal set. Candidate key can technically be one or more column, but it's usually a minimal set. Set it itself is a wrong number because set can have multiple items, but also set can have one or more items. So it's a minimal set. So minimal means one. I will not say null, but minimal is one. So candidate key is basically, I will say this is candidate key, this is candidate key, this is candidate key. Right now it's defined. Now primary key, you choose a primary key. Now why candidate key and primary key are now pretty much same. You will say why then primary key? Because the database runtime, whether it's any relational RDBMS system, they will use that primary key for indexing. So it's basically a way of explicitly specifying, hey database, use this column to index for your use case, right? Even for your implementation. So when you define a primary key, although technically candidate key and primary key, now you can say it's same, but when you define a primary key, a database engine use that to build the indexes. And when you specify the primary key, the remaining other keys, which can uniquely identify, became alternate keys, because they are also good candidate for the primary key, but it's just the case that we didn't choose them. And when you don't have any unique column with the unique values, then you can combine the different columns to make a unique key, or you can add UID. Nowadays, UIDs become a best practice to use for the defining identity for each of the row. I would say look into UID. That jargon that you see sometimes when you receive the data set, that hexadecimal combination of number and character, that's basically UID. And there is a GUID, which is also widely used term, and the mechanism to identify that. Just because it's like a 128-bit long, there's a quantillions, approximately quantillions combinations that you can generate. So you have large pool of numbers from which you can choose. And so that's why largely people use UID, GUID instead of serial number. So alternate keys, basically the keys which haven't been chosen as a primary key are alternate keys. Foreign key. Now, if this table has, so the branch ID you can see here, I referred as a 1. So this branch ID basically refers to the another table which has branch names. So this is a foreign key because this is a foreign entity added here to this table. Whereas if you want to find what this branch ID means, you have to go to the respective table to see what that branch ID means. So that's why it's a foreign key, because this is working as a primary key in its own specific table. But the table which is referencing it, you will call it as a foreign key. And then while defining the table structure, you basically define that this is a foreign key coming from this table. This is basically, it gives you consistency, right? Suppose I want to add a branch which doesn't exist here, then because of that constraint, it will not let you add that value in that record. Suppose I define something which doesn't even exist here. Suppose I do like EE branch, which is not here, but I'm trying to add it here, the reference number. Or even I can use this column names as a ID and then just type it here, which will be invalid because that EE doesn't exist. So that's why you build relationship because you want to keep it consistent. Suppose you delete here, or if you suppose I delete CS from this branch, you can do cascade delete. Means suppose I delete here, you can technically delete this, but that's a very weird way of managing records. You should be just nullifying this so that it says they don't have any branch associated with it when you deleted it because it was referencing this. So that's the relationship. Having that relationship is basically helps you to maintain the consistency and data integrity across the table, because you don't want something which doesn't exist, but you're still differing, then that's inconsistency. So that's why when you, as an employee at Rutgers, if I delete your record, a lot of other information with you will go away, because that's how the information is stored. It's relevant to you. Technically, web applications don't delete the data right away. They still keep it in a sleeping state, inactive state. You just don't see in your application, but behind the scene is still sitting there, which is marked as inactive. But in most of the case, you delete it, so then you delete all the relevant entries that is for that specific employee. So if for myself, for example, I'm the employee of Rutgers, if someone deletes my record, then basically they will have to delete all the entries from my salary table, from my, if there is some other table which says that I belong to this IFH IT department, then relationship that will also need to be deleted because I doesn't exist, so that relationship it's not valid. So that's a defining relationship is very important. Now, those are specifically key. There are some queries that we will go into, but looks like we are running out of time. So I would say go through this, and then once you know this thing, writing queries is a breeze because SQL is a finite, has very limited set of things that you can do, just like GitHub, Git. Only there are a specific set of commands. It's very limited. Whereas other languages, you can build upon things. You can build a language using another language, blah, blah stuff. You can technically do that SQL, but still very limited. So when you have this best concept, writing queries is much easier. So we will do quiz in next session, whoever does good, will get them pizza. So going through this is very important. So I will say, go through this basics. We'll do a small quiz, and then we'll go into writing queries and all that. There are some basic queries I already included. Suppose you want to, for example, if you want to build a table, if you want to use this as your practice resource, right? Now I'm building this table now. Also, you can just copy this. There's insert records. And to show you the example how you can practice at home. Now I will click build schema, right? And now this schema is built. Now this right-hand side panel, you can do, you can just write the query, run it. It will show you all the records from that, the one that we just added, right? So this SQL Fiddle, it's a very lightweight, something that you don't have to deal with the other complexity of installation, but still we'll go through the stuff for each specific databases. For practice purpose, just use this, right? It's not any production data or something that will matter a lot or will cause issues, something. It's not like that. So you're just for practicing. The technology is very beautiful. Someone always find a way of doing things in a very natural way and simplest way. So use SQL Fiddle, learn, and then we'll go into the actual implementation. So you can use this. There are a few queries. We'll go through these queries also. Star means everything, which is very common term usually in even SAS and other places also. We'll also go through that other stuff. But I guess we will, as per I know, it's 2:29. Any questions?
I just wanted to say thanks, Dinesh. I know the subject matter is a little dry when you're just giving the basics.
Yeah.
But
It is.
you know, it's important to have the foundational knowledge of definitions and terminology.
Yeah.
Yeah, I agree. Thank you, Dinesh. I know this is a lot to go over, but I learned a lot. A lot of this terminology I heard you use in the past, didn't quite understand how it was all connected. So thank you.
And now we know what a tuple is.
Yeah, I pronounce it wrong. So yeah, even SQL, there are many ways of saying SQL. Some say SQL.
Yeah.
I will be always in confused state, but I just use SQL. So, but anyone else has question, please, this is the time to ask. And also, these are very hyperlinks. If you even click on this, the Markdown language is very nice thing to learn. You can also click on edit thing because it's a public, and you can also see how the Markdown is used to specify the content here. If you want to learn the Markdown language also. But yeah, we can do the presentation without using PowerPoint. This is the power of Markdown, basically. Any questions from anyone else? Any comments?
Well, thank you for the marathon training session. I appreciate it.
Yes, thank you.
My pleasure. Okay, so we can maybe end the meeting here. I know Murray recorded the session, so if someone wants to take a look at it later, we can share this. Also, we'll put this series on IFH YouTube channel, and we'll make it accessible to everyone to see it. Look at.
Oh,
Thank you.
thank you.
Perfect. Hey guys.
Bye-bye.
Thanks, Dinesh.
Not a problem.